Okay, so this entire flashback is asking you to predict products for a double replacement reaction. So, double replacement reaction is very similar to single replacement reaction, but instead of one element switching places with another, we got two elements switching places with each other. So, when that happens, someone from here is going to switch places with someone from here. Now, how do I know who is going to switch places with who? Well, it's always going to be the like charge. So whoever is positive over here is going to switch places with the positive guy over here. Okay, you can also look at it the other way. Whoever is negative over here is going to switch places with the negative guy over here. Now, it's much easier just to look at the positive guy. So let's determine who is the positive charge on this side. Well, here, this is a transition metal. So since that is a transition metal, they give you the charge, and you can see it's positive. Okay, so he's our positive, and chlorine has a charge of -1, so he's our negative charge. Then we look at HF. H has a charge positive, and fluorine is a negative charge, so he's negative. So if positive is going to switch a positive, that means Fe is going to switch places with H. To give you your new products of FeF plus HCl. Now, do not write this as ClH because the one who's positive must always be written first, and the guy who's negative is written second. So that is a common mistake people typically make, but don't do it that way, okay? Make sure the positive guy is written first. Now that we have predicted our products, we need to make sure our formulas are written correctly. And we do that by doing crisscross rule. Okay, so let's do it for FeF. Fe's charge I know because they give it to me as +2. And F's charge, I look at the periodic table, I find it to be -1. Okay, so crisscross rule, you just switch the numbers, don't worry about the charges. So you bring down the 1 here and the 2 here to give you Fe1, F2. Remember, typically we don't show the ones, so it's just FeF2. So I need to put a 2 right here to show that that is how you correctly write the FeF formula. So it's FeF2. Now let's look at the second one, HCl. H's charge, I look, is +1. Cl's charge, I look, is -1. Okay, so switch them. H1Cl1, we don't show the ones, so it's just HCl. So he's written like he's supposed to, he's fine. This is why you have to do crisscross rule, because it doesn't always work out that way. Okay, the first one showed us that. So you have to be sure to make sure you're writing these correctly. All right, and we don't have to worry about diatomics here because there is no element by himself, so we can skip that rule. But in single replacement reactions, we have to make sure we do that. But in double replacement reactions, we don't. So we are finished. Everything checks out to be okay, and we have our products Fe2 and HCl. Now you can use this process to help you answer question 1 correctly.